Howdy! Today we're going to talk about concavity and inflection points. Alright, concavity is really having to do with the shape of the graph, and something we say is concave up if it has this shape, and people think of it as the shapes that hold water. So this is concave up. But even half of that shape still counts as concave up, so things with this shape, at least they're trying to hold water, that's concave up, or things with this shape, trying to hold water again, at least, all of that's concave up. Concave down is the reverse. Those are those functions that want to dump the water out. So things like this, they just want to have all the water leave. That shape is called concave down. And again, half of it counts, so graphs with this shape, again, are concave down because the water's falling out. And graphs with this shape are also concave down because the water's falling out. All right. Now, let's look at concave up here for a moment. Remember the picture was this sort of shape. You notice that over here, the derivative is negative and might be -1 there, whereas over here the derivative is flat, so it's 0. And when you get over here, the derivative is turned pointing up, and it looks about 1. And as you see, concave up is really just meaning that the derivative, f prime, is actually increasing. That's the real definition of concave up, that the derivative is increasing. So, we know, of course, increasing derivative is the same as saying the second derivative is positive. In other words, f prime prime is positive. Okay? And a similar story goes for concave down. Concave down is when the derivative is decreasing. All right, so here we go. Theorem says the following, that f is concave up is the same thing as saying that the first derivative is an increasing function, and it's the same thing as saying the second derivative is always bigger than 0. So this is usually the easiest one to check. Similarly, we'll say that f is concave down if and only if the derivative is decreasing, if and only if the second derivative is negative. And again, this is usually the easiest to check. Just take the second derivative. If it's negative everywhere on the interval, then the function's concave down. Okay? You can also have things switching from concave down to concave up, sort of this type of shape. And you see it kind of switches around here. So this would be concave down. And over here it would be concave up. And so this is where the second derivative will be negative. Over here, the second derivative will be positive. And so if it's negative here and positive there, it had to switch in the middle, so the second derivative will be 0 there. But when this switches concavity, this is called an inflection point. So the definition is just this: when f switches from concave up to concave down, or vice versa, you get an inflection point. And as we said, going from concave up to down, either the second derivative switched from negative to positive, or it switched from positive to negative. So that gives us this. It says when f double prime changes sign, there is an inflection point. And we'll do an example of that next. See ya.